So this video is an introduction to the GNSS planning online. So it's a tool, an online tool that you can use to get a sense for which satellites you're going to have access to when you do your work, and also things related to skyplot, DOPS, number of satellites, etc. So there's some really neat tools here. So to get here, what you have to do is, I'll just pick a new tab here, is go to, if you just Google Trimble planning software, this is a GNSS planning online. And what you need is Silverlight, so you may have to download that if you don't have that on your browser. So I'm just going to go back here. So basically what you do here is you figure out the settings that you're going to use and which day you're going to be working on. So you start with your location. So what I'm targeting here is I queried Vancouver, which zoomed me in here, and then I went to Deer Lake, which is where we're going to do our term end project. So I put my cursor here, your position, and now I'm in Deer Lake. And now I'm going to apply. So now I'm going to pick the day that I'm working at. So for instance, your first field day might be, oh sure, we could go with today, but you're going to be in the future. We're going to go with, say, Friday, April 1st. And then you're going to pick the visible interval. So let's say we're starting at 8 a.m. and we want a 12-hour time span. So we want to see what satellites we're going to expect during a 12-hour period. Height is related to the height of your antenna. So I'm going to put 2 meters. And then cut off, what this is your elevation mask. So you can set this to be 15 degrees, which I think is a good mask. What you can also do with this tool, which is pretty cool, is you can, yes, let's apply the settings, is you can set obstructions. So earlier I set an obstruction, which is what you're looking at right here. So normally what you see initially is, let's clear it. This is what you normally look like. So it means that you have a 360-degree view of your sky. There are no mountains or any buildings or anything obstructing. Now let's say you were working in Maple Ridge. So north, or let's say like you were at the Woodlot or a little bit higher in elevation. So north of there, or in this sort of general area, you would have an obstruction where part of the sky is being, maybe not this part, is being obstructed by mountains, so the Golden Ears Mountains. So you can set this obstruction, which will affect which satellites you might have access to, and your DOPS as well. So let's clear this for now because we're at Deer Lake. Now once you've set your settings, you have made changes, yes. So we're going to be working this day, you apply. Now what you can do is you can go to your satellite library, so it's going to tell you which satellites you have the option to collect from. Now we won't have access to GLONASS, remember those are the Russian satellites, or Galileo, or that's the Chinese, and I'm not even sure what that is. So we're only going to have access to the GPS satellites. So now what this is going to do is going to predict, using the almanac, how many satellites you could expect to have access to at each part of the day. So from starting at 8 a.m., it seems like there's some points in time during that day, like in the afternoon, where you're going to have access to more satellites, and then some other parts of the day you're going to have access to fewer satellites. You also get a sense for your DOPS. So remember, there's different types of DOPS. There's vertical, horizontal. Don't worry about these, we haven't really worked with these. But essentially, if you consider your horizontal position, so this is going to be your DOPS that you would expect to have at different times of the day. This is telling you which satellites will be visible at different parts of the day. And which, again, you have a sky plot view. Now let's say we did this work yesterday. So we're going to change the date. Okay. The other cool thing, I'm going to apply that. So we've already done the work. Now remember, when you've already done the work, now you have access to what is called the, anybody? Not just the almanac, but the ephemeris. So what you can also do is go to the ionomap and have a look at how much ionospheric interference was happening in our part of the world. Now, I had to Google what this meant, TEC. So TEC seems to stand for total electron content. So in interpreting this, what I see is that there's a lot more ionospheric interference happening in the southern part of the hemisphere, not so much in North America. But again, we could look at different dates when we may have done some work, and we could see what that might look like. Again, in the southern hemisphere. So that's another sort of perspective on how you can plan or get a sense for what quality of data you may be acquiring. Now, I wanted to show you one last thing and come back to this obstruction tool. So remember how with our current settings, our DOPs are pretty decent, right? Like they're quite low actually. Our horizontal precision is going to be under 2.5 for the most part, and the number of satellites we're going to have is at the lowest amount is 5. But now let's say, like I said, we're working in so click on this. We're working in Maple Ridge, and we're shrinking our sky because we don't have. Come on, there we go. Drag it out. Let's say this is the golden years. So do you see what I'm saying? So from if you were standing here in the northeast part of the sky is being blocked by a series of mountains. So in other words, satellites outside the blue line will be excluded from any calculations. So we're going to apply this and apply. Now let's look at our DOPs. Oh, accept. So now our DOPs aren't quite as good. A little bit, not bad, but number of satellites starts to drop. So we have parts of the day where generally what we're acquiring is 5 satellites and then going as low as 4. If you were working in an area that had even more obstruction, and you're thinking about having trees that are also obstructing, and you apply, you may get to a point where you can't even collect any data. Number of satellites. You know, at this point, we've got some points where we're borderline. We need a minimum of 4. So if there's any other interference happening, you won't even be able to collect any data. So this is a really helpful tool if you're going into a new area to play around with.